Hello, in this video I'd like to talk about the pipeline we are using for the Varroa Destructor project from the German Mindbusters. We are actually using two different pipelines, one which is shown here, which is for the main project, and another one I will show later for labeling or for assisting labeling of the images. So the main project comprises two hardware devices. On the left side we see the Oak D, which is our camera, and on the right side we use a Jetson Nano as the host computer. Even though we are using a Jetson Nano, the actual networks are running on the Oak D. So the first piece of the pipeline is the main camera of the Oak D, the color camera. And initially we did not use the full pipeline. We started introducing the different pieces step by step. So as a first step we were only using the main camera and piping the image straight to the Jetson and displaying it, just to have a first working prototype. And then we were able to expand. So we started scaling the preview and feeding that into the detection network. At the beginning, this was just a random detection network, which was not focused on detecting bees, but only on detecting something. So it was the mobile net without any special transfer learning done. Just again to have a proof that the system is working up to this point. And we were displaying the bounding boxes straight as in the results too, as well as the image, of course. We are using the scale preview to increase the network performance. Once that was done, we started introducing the health classification network, which is a second step in the pipeline. This pipeline actually uses two different networks, one for the bee detection and one for the health classification. And both of them run in series. So for each detected bee from the bee detection network, the bounding boxes are transmitted to the Jetson. And again, in the first step, we just made a turn and used the crop bee images. So we cut out the piece of the image where the bee is and run the health classification only on that part of the whole image. Once that was working, we then started to implement the bee tracker. This is a little out of date. In the meantime, the bee tracker is actually also running on the Oak D, where the depth AI Python API allows for a object tracking piece in the pipeline. So here's the whole setup. The main camera outputs a scaled preview, which is used for performance reasons as the bee detection input. We show the base image on the screen while using the bounding boxes of the detected bees to track them over multiple frames to see where they are moving. Each individual bee is cropped from the whole image and classified by its health. We then pipe the health information back into the host PC and combine it together with the bee position from earlier and output everything on the image. This is the pipeline used to assist in the image labeling. We are using label image with a manual setup, but in this case the same hardware setup as used in the main project assists with labeling lots of images. Instead of having the input coming from the Oak D camera, we are piping the image from the host PC into the same bee detection network running on the OAkD as in the main project. This time only the bounding boxes are extracted and they are going back into the host PC. The host knows which image it just has sent, and so it can combine this image file together with the returned bounding boxes and store them in a format that is readable by label image. This way we can then later go back and manually adjust or add missing bounding boxes.